I'm Bryan, and I'm here to talk to you about transpiling and why I think it's so great. So first, the obligatory, what do I mean when I say transpiling? For the purposes of this talk, when I say transpiling, I'm talking about one of a number of languages that can be automatically translated into JavaScript and then executed as native JavaScript. But I'd really like to dig into the background behind this word to sort of give some meaning into why the word exists. So as Wikipedia likes to say, transpiling is a portmanteau of translating and compiling. And what's interesting about this is that compiling is already a kind of translating. I mean, compiling is you take some high-level source language and you translate it into like bytecode or machine code or something like that. So really adding translating plus compiling is completely redundant. So why would anyone invent this word? And I think the reason is that when people think of compiling, they think of starting with some high-level language and then ending up with something that's like svelte and efficient, like bytecode. And when people think of JavaScript, svelte and efficient are not the first words that usually come to mind. So I think when people started thinking about compiling to JavaScript, it made them really uncomfortable to think of like this being an actual valid compile target. So they made up this word transpiling that has sort of this different connotation of rather than ending up with something svelte and efficient, we end up with JavaScript instead. And I will leave it up to you to decide whether or not that is a fair assessment, whether or not we should keep using this word or just call it compiling. I'm going to keep using the word transpiling, at least for this talk, just because I find it a really fun word to say. Now, if you know any transpiled language, the elephant in the room is kind of CoffeeScript. It's by far the most popular transpiled language. And there are a lot of great things about CoffeeScript, but my talk is not really about particular languages, but about what they bring to the table. And so for each one of the languages that I bring up, I'm going to mention a particular quality, I think, that it really adds to the world of JavaScript. And so what is the main benefit that we get from using CoffeeScript? Well, brevity mainly. CoffeeScript lets you write less code. So for those of you who aren't familiar with CoffeeScript, this is a language, a very popular open source language developed by Jeremy Ashkenaz, who is also responsible for Backbone and Underscore, and so it works really well with those. And like Underscore, it does a lot of papering over the rough edges of JavaScript that let you write a lot fewer special edge cases. But it also provides syntax that just makes the syntax of JavaScript shorter. So let's look at an example of this. I've just used a couple of the features of CoffeeScript here. We've got JavaScript on the left and then the equivalent CoffeeScript on the right. And the features that I'm using here, kind of going down the code, first is this @ sign that you can just use instead of this dot. And that seems like a really trivial thing, like, oh, I just saved myself typing 4 characters. So why do I care about this? Well, it turns out you type this dot a lot when you're writing JavaScript. And likewise, at the end of that line, there is an arrow operator. And that arrow operator just keeps you from writing the word function. And again, it seems like not a big deal, right? But you end up writing these words so often that it really adds up. And in this case, you'll notice it's not the regular arrow, it's actually the fat arrow. And what the fat arrow does is it provides what you would call lexical binding for this. So it basically captures the value of the this keyword at the time the function is defined and uses that as the this value whenever the function is called. And so that saves you from, in this case, explicitly capturing this as self, or from using underscore.bind or underscore.bindAll. And like I said, these things really add up. So like in this example, we end up with 32% less code. You've got 122 characters instead of 179. And I don't think that's particular to this piece of code. Any JavaScript that you write is going to have the same sort of reduction in size. And I think there are some times when this is really, really helpful, especially when you're working on a small project, like a side project that you're the only one working on, or you're a small team. Basically, anytime that you would find Ruby the correct programming language to use for your backend, CoffeeScript is going to have a similar set of characteristics that make it desirable. So like I said, especially if you're working with a small team and your primary, you spend most of your time actually just typing, this is going to save you a lot of time because you just have to type less. But that's just one of many things that you could be optimizing for, and you're not always on a small team. If any of you have ever worked at a company where you built everything in, say, Ruby on Rails, and then you scaled up, you know that eventually this kind of dynamic scripting untyped language is, or not statically type-checked language, is going to eventually give you a lot of technical debt. And as your team grows and you've got more people working on it, you can't know the whole code base, and you don't necessarily trust everybody who you're working on with the code base. And so I'd like to point to a different language that's better for some of those use cases. And that would be TypeScript. And if you're interested in TypeScript, you should have gone to Matt Harrington's talk this morning. Unfortunately, being near the end of the day means I can't plug other people's talks, but you should still check out TypeScript. It is a language that is being developed by Microsoft. If that scares you, it shouldn't. It's completely open source, and it actually has a really good pedigree, kind of like CoffeeScript. It's being developed by Anders Hallsberg. Apologies for almost certainly mangling his name. But he was originally responsible for Turbo Pascal and Delphi and C#. So it's got a pretty good pedigree. It's a strong language. But it also provides a lot of smoothing over some rough edges of JavaScript. But the thing that I'd really like to point out about TypeScript today is that it can provide type safety. Really, I mean statically checked types. So in this example here, I've defined an interface called person that has a first name and last name that are strings. And when I run the transpiler, not only does it translate this code into JavaScript, but it also checks that all of the types actually are correct. And I know I'm talking to a lot of mostly JavaScript programmers. If the last experience that you've had with statically typed languages was Java or C++, you should know that they've actually come a long way since then. And so one of the great things about TypeScript is that it has type inference pretty aggressively. So in this case, you can see in the last line, I'm calling the greeter function and I'm passing it an object literal. And I never actually said that that object literal was a person, but the compiler still knows. So it looks at the structure and looks that it actually has the properties and types that are declared in the interface, and then that's allowed to pass. So you only have to put types in there just enough for the compiler to sort of get a clue, and then it figures out all of the things that it can infer itself. And so that's a huge benefit over a lot of older statically typed languages. And so the benefits of doing this are not just that it's statically typed. I mean, that catches bugs sooner, and I know Crockford said that maybe it wasn't worth the freight earlier, but it not only can catch bugs sooner, but it also is self-documenting. And when you have a really large code base, anybody who's worked on a large CoffeeScript or Ruby code base knows when you see a function, you don't automatically know what's getting passed into it or what it might return. And so not only does the compiler get to type check these things, but also when you look at the greet function, you know it takes a person. And so it makes the code a little bit easier to read. So CoffeeScript can give you brevity, which is great for small teams, side projects, things like that. TypeScript is a little more enterprise grade, gives you more guarantees of correctness. But I promised you 7 ways that transpiling can make JavaScript better, so what else is there? Well, for the next language, I'd like to talk about Dart. So Dart is a project that's being made by Google. And it does some of the things that the other languages do. It has some nicer syntax for some things like CoffeeScript, and it does some amount of type inference and type checking like TypeScript, but that's not really what Dart is about. Dart is about speed. And so to demonstrate that, I'd like to show you this graph off of the Dart website. And I'm going to thicken those lines a little bit. So there's a couple of different ways that Dart runs, and that's why there's several different lines here. The top line is actually in the Chromium open source version of Chrome. There's a special Dart interpreter that runs Dart natively. And while that's really interesting, that's not transpiling. That's a whole separate runtime. So that's not really the focus of my talk today. I'd like to instead draw your attention to the bottom two lines. There's one there that's red and is going up and to the right. And then there's another one that's kind of flat line. And so what this graph shows is along the x-axis is the benchmark over time. And along the y-axis is the score. And bigger is better. So obviously you can see the native version outperforms everything else. But the line that's going up and to the right is Dart that has, I should say idiomatic Dart that has been transpiled into JavaScript. And the flat line is just idiomatic JavaScript. And so I think this is really interesting that if you just write Dart and transpile it into JavaScript, at least for some cases like this benchmark, it can be faster than if you'd written it yourself. And I think that surprises a lot of JavaScript developers, but it probably shouldn't. Because we went through the same thing in like the 70s and 80s with C compilers. It used to be that if you were writing a game or something and you had a really tight loop in C or Pascal or whatever, you would want to rewrite that particular loop in assembly language to eke out every last bit of performance. And a typical programmer could make assumptions and write assembly language that was faster than the code generated by the compiler. But compilers and optimizers got a lot better over time. And so one engineer who's really an expert and really knows assembly language really well can implement an optimization in the compiler that maybe isn't intuitive, and it will perform better than like 99% of other programmers trying to write it themselves. And so today, it's usually kind of ridiculous to think that you could write assembly language that would be any faster than if you wrote good C code using proper algorithms and had the compiler deal with the optimization. And while in probably the typical case, you're not going to get that kind of boost from transpiling, it's starting to be true for JavaScript too. And in this benchmark, it's true. And it's probably just going to become more and more true over time. And this is something that I see even in like CoffeeScript, where speed isn't necessarily the main objective. Every once in a while, if you read Hacker News, you'll see someone come on there and complain that CoffeeScript is really bad at generating code because they generated this particular JavaScript, whereas that developer would have written it by hand completely differently and it would have been much more efficient. And then someone comes in and actually does a benchmark between those two things and finds that the CoffeeScript version is actually more efficient for some reason that's maybe not intuitive or that not everyone knows. So I think, you know, like I said, in the long run, transpiled JavaScript can be faster than handwritten JavaScript because you write in a higher level language, write something idiomatic, and then the transpiler can do the work to actually optimize it. So yeah, you can write code faster, you can have it be more correct, and then you can have it execute faster. So what more could there possibly be? Well, there's a couple of things, and the first one that I'd like to point out is that you can get new language features from transpiling. And so to talk about that, I'd like to draw your attention to probably the most obscure the most obscure language that I will use in this talk, and that is iced CoffeeScript. And as you can probably tell from the name, this is a fork of CoffeeScript, but it really only adds one major new language feature. And in order to understand that language feature, you kind of have to understand how promises work. And anyone who knows me, has seen me talk, or has been unfortunate enough to like be next to me at a Christmas party knows eventually I will start rambling about how great JavaScript promises are. This talk is no exception to that. For those of you who don't know, a promise represents the result of an asynchronous operation. And basically, you should use them in any case where you have lots of asynchronous calls instead of using callbacks, and they allow you to write much cleaner code. So for example, this is just some CoffeeScript that is using callbacks to do some asynchronous work. Now, like 5 seconds, what does this code do? I think this is pretty hard code to read, but it's just calling, it's going through a list of keywords, and for each one calling an asynchronous search function, and then gathering all of the results at the end. but it's pretty hard to read. And you could clean this up a lot by using promises. So this is the example using promises. As you can see, it's much shorter. You have a for loop, you do the search, you don't have recursive callback spaghetti. So I think that's a pretty big improvement, and this is really a much better way to write asynchronous code once you learn promises. But if there's one thing that I've learned working at Parse and dealing with external developers, it's that almost no JavaScript developers out there really understand promises. At least there's a very small number of you. So wouldn't it be great if we didn't have to write this kind of code at all? If we could just write straight inline code that looked like it was making blocking calls and let the transpiler deal with this for us. And so there's actually another language that historically that has solved this exact same problem in an interesting way, and that is C#, surprisingly. So C# has a library called the task parallel library that provides a couple of classes like, for instance, task. And a task in C# is almost the exact same thing as a JavaScript promise. The names and the names of the functions, the exact APIs are a little bit different, but like for most intents and purposes, it can be thought of as the exact same thing. And Microsoft already ran into the same problem of people don't really understand how to use tasks, especially with the name task and continue with a continuation. It really sounds a lot more complicated than it probably is. So in C#, they invented a new language keyword called await. And what happens is when the compiler compiles some code that has await in it, it breaks apart the state machine of the code and reconstructs it so that it uses tasks. So what you see here is this is the same piece of code written with tasks, or with tasks specifically on the right. And on the left is the async version that you can write in C#. And these two pieces of code, I mean, other than some fudging that I'm not a manual compiler, these are the exact same implementation. And so wouldn't it be great if we had a language where you could put the await keyword in your JavaScript, and when it transpiled, it broke apart for loops, broke apart function calls, and reconstructed it so that it used promises. And that's essentially what iced CoffeeScript is. So you can basically think of it as adding the await keyword to CoffeeScript. And it's slightly different here because their implementation is not exactly the same as what you see in C#. In this case, they actually use defer with a callback, which is complicated and I don't want to explain right now. But the basic idea is that when you put await in there, it allows it to break apart the code and rebuild it so that it does things in a correct asynchronous way that you can reason about without having to write all the callback spaghetti. And that's basically all iced CoffeeScript gives over CoffeeScript, and I'll talk a little bit more later about why the await keyword isn't necessarily in CoffeeScript. But I know some of you are going to think, well, this is like way too obscure of a language. Why would I go use iced CoffeeScript? But just because you may or may not choose to use obscure languages doesn't mean that you can't benefit from getting new languages because of transpiling. There are many projects, such as Facebook's Regenerator project, that add new ECMAScript features into older versions of JavaScript by transpiling them away. And I've already talked about some of these, like in TypeScript, you can use the class keyword, and it's just an implementation of what will probably be in future versions of JavaScript. And the transpiler compiles them away, and you end up with JavaScript that runs in browsers today. And Facebook's Regenerator project is kind of similar. It actually provides the yield keyword so that you can use it in browsers, which lets you write generator functions. So even if you are uncomfortable with the idea of using some transpiled hipster language or something, you can still just use new ECMAScript features by using transpiling, and it's relatively low risk. You can always just switch to using the output of the transpiler if you decide that you don't want to use that language anymore. So like new language features are pretty cool, but the best part is that they also allow you to have completely new design patterns. And so to illustrate that, I'd like to talk a little bit about ClojureScript, which is kind of like Clojure for JavaScript, which is kind of like Lisp for Java. how many of you have ever had this argument between two engineers where one of them wanted to have a singleton object that stored your application state and globals versus someone else who wanted to have an application context object that you pass to every single function? I know that I've had that. I mean, like, maybe I'm just an argumentative person, but I have that argument like 2 or 3 times a year. The benefits of having the global object is that you don't have to have every single function pass this context around, and where the context has to know everything about every single detail at the leaf nodes of your code. But on the other hand, if you use a global singleton, you can't do dependency injection very easily. If you modify it, it modifies everyone else's code everywhere. Well, the bad news that I have for you is if you've been in that argument, you were both wrong. And actually, as with almost everything in computer science, Lisp actually had the correct solution for this back in the 70s. And that is something called dynamic binding. And I know, like, with a lot of JavaScript programmers, when I bring up dynamic binding, the first thing they think of is the this keyword, which is an example of dynamic binding, but it's like dynamic binding the bad parts. What dynamic binding allows you to do is you create a variable that's called a special variable. And this variable doesn't change in the sense that there are no side effects. There's no global changes to it. But what you do is in your code, you can rebind it. In Lisp, it would be a let binding, but in ClojureScript, you just use the binding form. And you can rebind it to a new value. And what that means is, rather than actually changing the value of the variable, the way to think about it is like you have a thread local dictionary where you've pushed a new value for that variable onto a stack. So when you set a new value for it, it only affects the thread that you're on, and only for the functions beneath you in your call stack. So this is sort of a contrived example I have here based on a place where I really wanted to use it but couldn't, because at Parse we don't use ClojureScript. But at the top I've declared a dynamic variable called useMasterKey. And the reason for this is in the Parse APIs, you have client keys and you have master keys that are sort of like calling your API methods with root. And we have a bunch of APIs, like you can see here, fetch, save, and destroy. I've mocked out all of the implementation of them. But with any one of these API methods, you could call it as a regular client, or you could call it as a root. But the implementations of those functions don't really need to know anything about that. All that really matters is that when we do the HTTP request at the end, we send along the right root or client key with the request. And when I implemented this in JavaScript, what I had to do is I had to go plumb passing useMasterKey through every single function. I had to make sure fetch knew how to pass it on to the HTTP request, and save knew how to pass it on, and destroy knew how to pass it on. And it was a lot of code, and it leaked a lot of implementation details that all of the stuff in the middle didn't need to know about. And so with the dynamic binding, since I have useMasterKey dynamically bound in this example, I can either call fetch, in which case it remains false and the HTTP request is false, or if I use this binding special form, I can bind useMasterKey to true. And then once I do that, when I call fetch, useMasterKey is sort of passed along as an implicit function parameter. So it doesn't actually change the value of useMasterKey for any other thread or for anything else that happens after this call. It just changes it for that fetch call. And it gets propagated down so that when the HTTP request gets called, useMasterKey is true there. And so this lets you do dependency injection by changing what binding you create at the outer level. And it also keeps you from having to leak all the implementation details to all those functions in the middle. So this kind of shows that once you have these new language features from transpiling, not only can you use the features themselves, but you can like actually architect your software differently to make it more manageable. So to recap so far, we've looked at you can write code faster, you can be more confident that it's correct with static type checking, you can have the code execute faster, and you can have new language features and new language features and new design patterns that come out of those. But that's just until you've actually written the code. Once you've written the code, transpiling can still help you out, and the reason for that is source maps. And so I'm cheating a little bit here that all of my other examples are particular languages. Source maps are not a language, they're a technology. And the way to think of source maps is kind of like if you were compiling C and you include debug symbols. What happens when you transpile a language that uses source maps, such as CoffeeScript or TypeScript, is it not only produces the JavaScript that's equivalent to the input, but it also provides a mapping of the code in the original language to the output JavaScript and vice versa. So for example, if you have say a console.log statement in a particular line in your TypeScript, it's going to have a reference to where that shows up in the JavaScript. And this is integrated into, for instance, Firefox and Chrome, so that when you're stepping through JavaScript code debugging it, if you transpiled it from CoffeeScript or TypeScript, you can actually step through the original TypeScript or CoffeeScript line by line in the debugger, and it just does the JavaScript stuff in the background. And to explain why this actually makes debugging JavaScript easier, I'd like to show an example here. I love underscore, but there are a couple of problems with it. One thing that's not a big deal, but it's just sort of a constant minor annoyance, is that because it's functional, it can be a little bit irritating to debug. And so, for instance, here I just have a simple map that maps over the items in a dictionary and creates strings out of them. Now, if you're stepping through this code in the debugger and you get to the line that has the underscore.map in it, and you want to step through each line of the loop, what do, right? If you step over, you're going to step over the whole call to map and go straight to the console.log and miss everything. But if you step into, you're going to jump into the implementation of underscore.map. And that's kind of like if you were debugging some C code and you accidentally step into some assembly language. It's going to be a bunch of stuff that you don't really know what it does half the time. So what you end up doing is setting a breakpoint inside the map and one after the call to map, and then just using continue and catching yourself on breakpoints. And that's doable, but it's just sort of a constant minor irritation. And so wouldn't it be nice if you didn't have to necessarily use underscore like this, but you could use a language that just provided map as a high-level feature? For example, here's a screenshot of some CoffeeScript that's the exact same functionally equivalent code in the Chrome debugger. And so as you can see, because CoffeeScript has this for keyword that returns a value, you can actually construct the same kind of map in the language itself without using a helper function. And so the result of that is that when you're in the debugger, you can actually step through the lines of CoffeeScript, and if you're on this line with strings equals, you can just say step over, and it'll take you to the next line, line 5, and you can actually just step through the loop one line at a time. So it's actually a lot more convenient. And this is sort of like a trivial example that, like I said, isn't too hard to work around, but like in the extreme, this can actually be really nice if you use a lot of functional programming. And to give you an idea of how much work is happening in the background, this is actually the JavaScript that was generated from that CoffeeScript. As you can see, it has like an outer function that's just a closure, and it has an inner function there, strings equals a function that's called. And so if you were stepping through this JavaScript in the debugger, again, you would have to like step into or set breakpoints or whatever, but because you're working in the high-level CoffeeScript, you just don't even have to think about any of that stuff. So I definitely think that source maps make dealing with JavaScript and debugging JavaScript easier. And so that was 6 things. So the last thing that I'd like to tell you about that I think transpiling makes JavaScript better is that it can let you group your view code together. Now, this one is probably the one that's most specific to JavaScript because of HTML. For an example, I'd like you to point you to the React framework, which is a framework developed by Facebook for generating view code. And the problem that it solves, at least I'm not a React expert, and if you were really interested in React, you'd probably be down the hall at the talk about React right now. But the biggest problem that it fixes, in my mind, is this. So I call this presentation spaghetti, but basically, when I use Backbone to create an app, I end up with a Backbone view, and it has a render method, but I don't want to create all of my views out of just a bunch of strings inside the view. So I end up creating an HTML template somewhere that has the HTML with the placeholders in it, and then I have to, for a single page app, include that template HTML in my main page's HTML. And so the different pieces of my presentation logic are separated into multiple different places. And that's just annoying to code. There are several ways that this could be fixed, and Angular is one of them that I won't go into because it's not really a transpiled language necessarily. But the way React handles it is with this language called XJS. And XJS is basically a superset of JavaScript that lets you put HTML literals inside your JavaScript code. And so in this example, it's just creating a simple item, a simple list of items. And you can see there's a couple of different templates here that might end up being different templates if you were just using underscore templating or something. But you can see there's just simply return li, item.title, close li, and then return ul, and then put a list of nodes in it. And it deals not only with the XJS part lets you just embed these HTML literals, which is much nicer than concatenating a bunch of strings, but React also lets you compose them such that when I put the item nodes inside the UL, since the item nodes are themselves HTML elements that were created from the LI, everything just kind of works. And so the difference between this and, say, Angular is that Angular tends to put the logic into the HTML, whereas React tends to put the HTML into the logic. And so, you know, while it's a good idea to separate out, say, your model logic from your presentation layer, it's really nice to be able to have the for loop that actually constructs the list in the same place as you have, say, the fact that it's a list item or the fact that it's an unordered list. So, just to summarize, those are some of the benefits that you can get from transpiling. You can write less code, which actually gets done faster. You can be more confident that it's correct because you can do static analysis like type checking. The code can execute faster. You get new language features that allow new design patterns. And it's easier to debug, and you can keep all your view code in one place. And so, why am I telling you all this? Why do I think transpiling is so great, and why do I think you should care? Well, some people have said that JavaScript is the assembly language for the web, and I kind of buy into that. And that's not necessarily to say that you should not be writing JavaScript by hand necessarily, but you know, today, there's definitely a time and a place where you'd want to write assembly language by hand, but for most people, most of the time, you want to write in a higher level managed language. And I think in the long run, JavaScript could be the same way. I mean, transpiled languages today are a bit of a niche. I mean, CoffeeScript is somewhat popular, but still by far the most popular is writing JavaScript directly. And in the future, that need not necessarily be true. It could be seen as like assembly language or C code today, where, well, you could write it by hand, but why would you necessarily want to when you could use a higher level language? Sounds a little bit ridiculous because JavaScript is already a pretty high level language, but as we've seen from like iced CoffeeScript and ClojureScript, there can still be higher level languages built on top of it. And so I think that transpiling means that you can be more than just JavaScript. And a lot of projects out there, like say CoffeeScript, to pick on it a little bit, they have a philosophy of being just JavaScript. And that has a lot of advantages that if you transpile your code from CoffeeScript to JavaScript, then you don't feel locked in because you can always switch to just using the JavaScript and debug it directly. And so they've kind of shied away from some features like the await keyword because necessarily the compiled JavaScript will be much messier and much harder to understand just looking at it as a JavaScript programmer. And I would kind of like to make an argument that we should not feel locked into just JavaScript. I mean, maybe that's okay for CoffeeScript or for some languages, but it's definitely nice to have some languages out there that give up on the idea of only being a loose translation layer over JavaScript, but really add diversity to the programming languages that are available and give us some new technologies. And in the end, rather than the language becoming just JavaScript, they can actually make JavaScript be a whole lot more. So that's all I have prepared, but if there are any questions, I'd be glad to take those now.
Of all these languages, which one do you write the most?
So the question was, of all these languages, which ones do I write the most? At work, I use JavaScript directly, mostly for historical reasons. But I would like to use more transpiled languages. In my personal projects where it's just me, I use mostly CoffeeScript because, like I said, I can reason about all of the code. I've written all of the code myself. I know what's in it. So I don't really need a whole lot of documentation, and it's mostly about just typing faster. I can certainly see myself, if I were working on a larger project, and if I were starting that project today, I would strongly consider using TypeScript because of the things like the static analysis. But like I said, when I work on the parse JavaScript SDK, we started that before TypeScript existed, so we just use JavaScript.